Okay, so let's go ahead and take a look at this problem here. If you want to pause the video and see if you can do this on your own, and then we'll come back and take a look at it. So if a random sample of 50 ATM withdrawals is obtained, describe the sampling distribution of the means. In other words, how does the sampling distribution look? What's its center? What's its spread for all samples of size 50 from this population of ATM withdrawals? So again, we're looking at sampling distribution of size 50. So n is equal to 50. Well, if we start with the shape, now again, we knew that the original population distribution was skewed right. However, now that the sample size is 50, which is greater than 30, the sampling distribution of itself, the distribution of all samples of size 50 from this population will be normal. Why is that again? Because our sample size was 50, and that is, let me erase that, which is greater than 30. So there's the reason why this is normal now. Because even though the original population shape was skewed and not normal, the sampling distribution is. So the mean of this sampling distribution of sample means would be equal to the mean of the population, which again was $67. And then the spread, the standard error we call it, would be the population standard deviation divided by the square root of the sample size. It's getting late in the day, people. Which is, again, $35 divided by the square root of 50. And that ends up being approximately about $4.95, or I'm going to go out a couple decimal places, about $4.95. Now, again, these are the values we're going to use in our stat act when we want to find probabilities. So that leads us then into D, which says, again, if we have 50 ATM withdrawals, a sample of 50 ATM withdrawals, what's the probability that the mean of that sample of 50 will fall between $70 and $75? Now, we've already talked about all this before, but I'm just going to quick write it down. We determined it was normal from part C. The center would be the same as the population mean, which was $67. And then the standard error would be about $4.95. Like I said, I went out to a couple more decimal places. So what's the probability then that the mean of a sample of size 50 will fall between $70 and $75? Well, if you just go to your computer, again, we'll go to this and see what we get. Here we go. Our mean was 67. Our standard deviation was 4.949. We want a probability between two values, and we want to go between 70 and 75. And if you'll take a look again, we're looking at a probability. Let me make sure all this is right. 6, 7, 9, $4.949 between that 70 and 75. You get about 0.2192. Now again, this could vary a little bit depending on how you round this value. For instance, if I put this at 9.5, then you'll see that the standard deviation, it automatically changes these, so you got to go back and change them. You be careful of that. And you'll see it's about 21.92. So we go back here, and I got to make sure I hit 0.2192. There you go.